scooting these back because these will just keep moving forward all year.
Yeah,
Like
it looks a lot closer to the wall.
Yeah. But yeah, if I don't push them back sometimes, they can get all huddled up in the first half of the room.
You left it up there still. Thought you would take it down.
You thought I would take it down?
Yeah.
I'm gonna at least wait until you're out of here.
135.
Put a lot of magnets on there though.
I know.
Yeah, you're showing a lot of legs, so.
Oh, that's my bad. Did y'all get 135 last time too? Good question. I'm gonna check. You're like on Tuesday.
Yeah, it's like being so be on the exam part 4.
What about 135? I just saw it on Crossroads. Oh, okay, yeah, got it.
Okay, our bells are still turned off, but I do want to give you some homework points for that assignment we did together last class, which was topics on the AP exam part 4, or numbered as 135. So I will get that back to you today. I just want to give you a few participation points. So please make sure you either put that in Google Classroom or come throw it in the inbox for me.
Taylor's in line for grad tickets, so she'll be early.
Taylor's what?
Taylor's in line for the grad tickets, so she'll be early.
Ashley, school business. Thomas is able staff. Kevin's out sick. Alright, before we get going on here, I have a quick, like 4 or 5 question survey I'd like you guys to do. So there's a bit.ly link up there under the agenda. The number 2, 3, capital A, capital Q, capital U. I think it's like 5 or 6 questions, not very long, but I asked my group last year some of the same questions, and some of that I used to help make decisions for next year, but I'm also going to share with you some of what they had said last year. Since, yeah, this is an A week, so this will be the last time I see y'all before your AP test, so my last chance to kind of share some of that. So I'll give you a few minutes to get that pulled up and answer those. None of that is like tied to any grades or anything, so feel free to answer honestly. I think one of the questions does ask for your name, but that's only so I can correlate it with like how you felt about stuff versus how you actually did once I get your scores in the summer. So short of that, it's basically anonymous. I don't really look at that very much.
give everybody a couple more minutes here. If you're still finishing that up, that is fine. But I'm actually going to jump to number 4 here. So there is a bit.ly link on number 4. I think I may have mentioned this before, and this type of thing exists for probably all of your AP exams if you Google search it. But if you have a specific score that you are aiming for, of course every year is a little bit different, but this one you could say free responses. Let's say that you think that you're probably going to get about a 3 on each one. You can change all of those to a 3, and then you can kind of adjust your multiple choice here and see how many of them you would need to get up to like a 4. But have y'all ever used anything like that before? Okay. I just wanted you to know that that's kind of available, so if you're aiming specifically for at least a 3 or at least a 4 or something, you should have a general idea, I think, based on your averages from FRQs, what you should expect. Of course, some will go better and some will be more difficult, but it also gives you an idea of just kind of where you would land, and if it's lower than you expected, then hopefully that motivates you to put in a couple hours of study in between now and then. Okay, I'm going to fly through the first part of this, but I do have some stuff at the end that's a little bit different. So I've been showing this for the last several classes. Pass rates, certainly not an automatic. I only do that not to scare you, but to make you realize that you should study some, and you should certainly go into the test prepared to give your best effort. Some years it's harder, some years it's easier, but the percentages basically stay the same. Make sure that you give your best effort. Make sure you're showing your work on FRQs. If it's something in a calculator, make sure you write it down, and you don't have to do any arithmetic. Leave your answers to 3 decimal places. You should know which FRQs are most likely to be on there. Some reasons to take the AP exam. You guys shared several of these. My 6th period added some of these, and we added one last time, not here, but 6th period, that you guys didn't think of, which was, this is a good way to meet people, especially for you, those of you going on to college next year. You know, if you pass the AP test, you would be enrolled in Cal 2 instead of Cal 1. And we actually do some of Cal 2 in here. A lot of what we did second semester is Cal 2 material, not Cal 1 material. If you're in a new city, new place, you don't know anybody, and you're in calculus class and you did well on the AP test, starting up like a study group or offering to tutor people or charging people to tutor them, good way to meet people. Okay, so some of the same questions you guys just answered for me on that survey. This is what last year's group said. I just want you to see about how you guys compared. It doesn't really matter, like I don't have your information for the class because you guys just did it. But last year's group, this one surprised me a whole lot. And honestly, y'all's is not that much different. Almost half the people expected to get a 1 on this before the school year started. So I didn't get to ask my group last year about that because I gave it so late at the end of the year. But is that just because calculus has such a hard reputation, or?
Well, I didn't know like anything about calculus.
Well, I know.
Maybe
I'm not, well, I didn't mean it as like if you took it right then, what would you get? Just like what did you think you would do by the end of the year?
Oh.
Oh, okay. So it's the wording of the question. Okay, so I need to change the wording of the question. I got you. Okay, and then this one has the same graph on top. So this was before the school year started, and then right below it is right before the AP exam. So you can see it looks like the majority of people were expecting a 3, about the same number of people expecting 2s and 4s, and roughly the same amount of people expecting 1s and 5s. So this is how they answered before they took the AP exam, basically where you guys are at today. And then moving that one to the top versus how they felt after. And this is where I think it can give you some perspective. So it looks like number of 5s went up, number of 4s went up, number of 3s went down, and number of 2s went up. So most of the 3s kind of shifted to 4s and 5s, but in general, people felt a little bit more confident. Trying to steal my pass. People felt a little bit more confident right after they took it than where you guys felt today. So. Okay, and then I also took this part. You guys have not done this part yet, but I will. It's a little bit skewed because I didn't get to ask my seniors, just like I won't get to ask seniors this year either. But I will ask you guys in another Google survey after the AP test, how did you feel about it? And so this was the results from last year, what they thought they did after they took it, and then the results that actually came in. So nobody thought they were going to get a 1 after they took the AP test, but there was actually one person who got a 1. Number of people who thought they got a 2 basically stayed the same. Number of people who thought they got a 3, it's a little bit lower. Number of people that thought they got a 4 about stayed the same, and number of people who got a 5 went up quite a bit. So I don't know if that helps at all. I don't know if that helps you feel better about it or worse about it, but I felt like it's good for y'all to see perception versus what actually happens in the past, because that could apply to you here. Anything you want to ask about that? Is that about what y'all would expect? Any of that stuff surprising? All pretty normal? Okay. Alright, next up, the work I would like you to do today is I'm going to let you pick one more FRQ to do, but first, I have a video I'd like to show you. And I have not looked for it in a year, so as I said, I had 2 videos I wanted to show you the whole year. One of them was one of the AP reviews, just so you could see what it was like and to see if that was a resource you wanted to use. And I told you there was one other one that I wanted to show to you. Get it set up. And so for this one, you don't need to take notes or anything, but I do ask that you follow along. It's a 20-minute video, so this will push us right up until lunch.
From yesterday too.
Okay. So, I don't know, I think this one's kind of funny because I don't know, I lied to you guys, and that it's telling you that we had to spend all year learning calculus when you really only needed 20 minutes. So this guy's going to teach you all of calculus in 20 minutes. So of course, anything that would come up in 20 minutes is important stuff. So as he goes along here, I'm hoping that you feel like everything he says sounds familiar to you. And if it doesn't, then you might want to look it over before the AP test. But he's pretty silly about it. And obviously you can't really learn calculus in 20 minutes. But he tries to teach you calculus in 20 minutes. And I'll turn the light off. Anything before I start?
That could be you.
This guy?
Yeah, I can see you doing this.
No. I can't fake being this goofy.
To do the impossible. We're going to try to do all of calculus in under 20 minutes. So we have to rush really fast, go through the whole course. Let's begin. The first two basic issues of calculus. Two big questions. What are they? How do you find instantaneous rate of change? How do you find how things are changing instantly? And then, completely separate from that, how do you find areas under curves? Two completely different questions. Turns out answers are completely related. Let's see how they go. Question 1. Instantaneous rate of change. What are we going to do? Well, what you do there is you first remember what is rate? Well, rate is just change in distance over change in time. It's easy as that. Distance equals rate times time. Not a big deal. Okay, and what do you do with that? Well, if you graph a function that represents sort of distance against time, then what do you notice? If you want to look at the change in time and the change in distance, what do you got? You actually got a slope of a line. Right? It's a slope. Rise over run. Change in distance over change in time. Distance over time. So you got a slope. So automatically we see a really neat thing. We see that the average rate of change between 2 points is equal to the slope of the line connecting them. Well, that's really cool. By the way, what about lines? You got lines. You got lines. Okay, no problem. We can do lines. We can do lines. Lines. Y minus y1 equals m times x minus x1. This is the point-slope form. All you need to give me is a point on the line, x1, y1, and a slope, m. You give me those two pieces of information, I can always write down the line uniquely. Always. Never forget. Okay, fine. So now we're back here. Now we can find average rate. And what do we see? Well, in fact, a line that touches the curve at 2 points is sometimes called a secant line. So in fact, we just discovered that the average rate, change in distance over change in time, is equal to the slope of the secant line. Cool. So all you have to do, you want to find average rate, connect the 2 points to the line, find the slope, you got the average rate. No biggie. But that's not what we want. We want instantaneous rate. So how do you do that? Well, what would that be? Well, if I want to find instantaneous rate here, what would I do? I'd make that secant line closer, bring these points together, and look what I'm converging to. I'm coming to a tangent line. Wow. Instantaneous rate of change equals the slope of the tangent line. So we want the slope of the tangent line. Well, what's the slope of the tangent line? It's changing y over changing x, changing distance over changing time. But now the change in time from that point to itself is 0. 0 over 0. So I'm getting 0 over 0, which is complete garbage. And that is a big problem. Our first major problem of the course. Okay, so what do we do? Well, we can that. Distance equals rate times time. We're going to can that. Instantaneous rate of change. I really want that. So what do we do? Well, how do we get that 0 over 0 problem to go away? The answer is we inch up to it. We just approach the 0 point. And what would that look like? Well, let me remind you what you've done when you were a little teeny kid. When you were a little teeny kid, this is what you're looking at. You're looking at a value of function at a point. Value of function at a point. Okay, not a big deal. There it is. F of A, it's that point. But you don't know anything else about the function. You don't know what's going around there. All you're looking at is F of A. You open it up. Woohoo! The function is quite interesting. Who knows? Okay, but now what I invite us to do, and what calculus invites us to do, is to look at the function this way. Cover up that point and look at everything else. Open the window, look outside. That's what calculus is. And what you see here is we can see what things are approaching, and we can actually determine the idea of a limit. The limit is what things are approaching. We don't care about what actually happens at that point, only what things are approaching. Armed with the idea of a limit, what can we do? Well, now we can return to the question and figure out, let's take the limit as delta t goes to 0. What do we get? We get 0 over 0. That is called an indeterminate form when you get 0 over 0. So what do? You've got to do some algebraic gymnastics. You've got to factor the top, you cancel with the bottom, you can try to multiply by the conjugate, you can try to combine the fractions. There's all these tricks in the trade to actually reduce it to something you can actually find. You find the limit. Okay, but once you find the limit, you take the limit as delta t goes to 0. What do you get? You get the answer to the question. How do you find instantaneous rate of change? The answer is what we call the derivative. And what's the derivative? It's the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Looks pretty confusing, doesn't it? It's just rate. It's distance over time, but now I'm letting time go to 0. Not a big deal. So that's the derivative. Bingo. We're done with the first question. And so now what do we see? Well, we see now, when we come back to here, and the derivative, in fact, gives us the slope of the tangent line. Well, that's really cool. If you want to find the slope of the tangent line ever in life, you just take the derivative, and that gives you the slope of the tangent once you evaluate it at the point you want. Great. But for free, we answer the first question. Because remember, the derivative also represents the instantaneous rate of change. So you want to find out how things are changing? No big deal. You take a derivative, plug in, that will tell you how things are changing at that instant. Okay, great. So now we know all about how to graph these things, how to look at these things. The derivative is velocity, boom. We got all the way. Now let's take a look at some applications. What can we do with this? Well, how would we take derivatives of complicated functions? Well, you got a product rule. Remember the product rule. Don't memorize the formula, memorize the chant. First times derivative of the second plus the second times derivative of the first. So derivative of product is this. Not the product of derivatives. You got to use the product rule. We've got 5 minutes. Okay, folks, I got to move faster. What if you have a quotient? Well, then you use the quotient rule. And what's the quotient rule say? If you got a quotient, you take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's the quotient rule. That's what you use when you have a derivative of a quotient. Great, no problem. Now, what if you have a really complicated function? What if you have a function that looks like this? It's got insides. It's got guts right in there. So you've got something like this, and you want to take the derivative of that. What do you do? Well, you got to use the chain rule, folks. This is a thing that you can chain together. There's an inside, there's a block right here, there's a whole big block there. And then you've got an outside. Take the derivative of the outside. The derivative of sine of block is actually cosine of block. So it's cosine of block, and what's the block? The block is going to be 3x cubed plus 1, and then you multiply that by the derivative of the inside. And the derivative of that turns out to be just, let's see, 9x squared plus 0. So there's the derivative using the chain rule. The idea is to peel off like an onion. Just peel off, keep peeling off the outside until you get to the inside. Always remember though, when you take the derivative, it's if you have sine of block, the derivative is cosine of the block. Don't put the derivative in there, put the block and multiply by the derivative of the inside. That's the key to the chain rule. Now we got the chain rule. Okay, but what about when you have functions that aren't functions? Like what if you have things that are relations? Like x squared plus y squared equals 1, like a circle. How do you differentiate that? How do you find dy dx there? Well, the answer is we use something called implicit differentiation. Implicit differentiation, how does that work? Well, you've got to remember that dy dx, that's an object, that's a noun. And d dx is a verb, it's a commandment. You take the derivative with respect to x. So you differentiate this with respect to x, and what do you see? Well, you see something like this. What you do is, you say, okay, I'll take d dx of x squared plus y squared equals 1. The derivative of x squared with respect to x is just 2x, not a big deal. The derivative of y squared, remember how I think about this? I think about this as pumping all this together. And I see this as a block squared, so I actually use a chain rule, which we just developed. And the chain rule says the derivative of block squared is 2 block, and then I multiply that by the derivative of block, which is the derivative of y with respect to x. That's called dy dx, folks. The derivative of 1 is 0. And now you can actually solve this for dy dx by bringing this to the other side. That'd be a minus 2x. You divide by the 2y, and you see dy dx equals minus x over y. And there's the answer. That's implicit differentiation. Just go right through and differentiate implicitly. When you have a relationship, you can still find the derivative. Great, we're making progress here, folks. We are cutting through this stuff. Well, now that you have derivatives, what can you do with that? Well, if you think about it as velocity, you get instantaneous velocity. If you take the derivative of velocity, you actually get the change in velocity, which is acceleration. So we get acceleration now, we get velocity. Acceleration is just the second derivative of the position. So we can actually take derivatives upon derivatives upon derivatives as many derivatives as you want. So it's great. You can do that. So higher derivative, no problem. What can you use these things for? Okay, we know it's true for velocity. We can use it for velocity. What else can you use it for? Well, it turns out you can use it for linear approximation. Suppose you got some wacko function. You got some wacko function like this, woo, and you actually want to figure out the value right here, and you don't know what that value is. But you know nearby there's a point that you can actually compute. So what do? You find the tangent line approximation because you remember the tangent line closely emulates the activity of the function. Tangent line closely emulates the activity of what the function is doing. They look the same there. So you find the equation of the tangent line and then plug in the mysterious point, then you're all set. Because you can approximate the value by plugging in the tangent line. So how would that look? Well, that's called linear approximation. Here's the formula. Don't bother memorizing it. Just think about it. What you've got to do is you've got to find the equation of the line that's tangent at the known point, which is x here in this case. And this is going to be x plus delta x. The known point plus little t offset. So approximately equal to the derivative times the change in x times the function. Plus the function. So that's it. That's the whole thing right there. Linear approximation allows you to actually do things. Computers work this way. Computers know calculus. Everyone knows calculus. You gotta know calculus. Okay, now, what else can you do? Well, suppose that a derivative were to be 0. Well, how could that possibly happen? That could possibly happen because maybe the function goes like this, and I see the tangent over here has slope 0. Or maybe the function goes like this, and I see the tangent has slope 0. In particular, if the tangent equals 0, maybe we have a max or min. Also, maybe the slope or the tangent doesn't exist. Like if we have a wave kind of thing. A cusp. Very pretty cusp like the waves. Well, that might be a max, that might be a min. So in particular, you can find out when objects are maximized or minimized. You can find the maxima or the minima very easily by using calculus. What do? You take a derivative and you see where it equals 0. Or where the derivative doesn't exist, but the function does. Those give you candidates for possible max and min. And what can you use that for? Well, you can do all sorts of max and min problems. You want to maximize profit, you want to minimize costs. Oh my God! 20 minutes? No. It's only 10 minutes left. I'm trying to fool you here, folks. I'm not going to go up for it. 10 minutes left. Okay, so you want to maximize cost, you want to minimize cost, you want to maximize profit, you want to maximize area, you want to minimize volume, whatever it is, set up the problem really carefully, figure out exactly what you want to optimize, take the derivatives, set it equal to 0, solve, find out where the derivative is undefined, and you've got it made. Really not a big deal. However, you should always remember and never forget the fundamental method of solving problems. So remember how you solve all of life's problems. The first thing you have to do is understand what you're being asked. You can't answer a question that you don't understand. The next thing you do after you understand what you're supposed to find, what you're being asked, is figure out what you know. List every single thing that you know, every single fact. Maybe it's superfluous, maybe you don't use it, who cares? Write it down, understand it, make it your own. And then the last thing is, take the information that you know and see a relationship between that and the thing that you see. Try to find a connection. Once you got that connection, then you're on the road to actually find the solution. That is a simple method for finding any single answer to any single problem. Another application, if we think about derivative as a rate, is looking at related rates. Suppose, for example, that you actually have a ladder, for example, that's falling down. The ladder is falling, and you don't want to be sued, but the only thing you do know is how fast the bottom is falling, you want to know how fast the top is falling. What you need to do there is, if you know this rate, you can find that rate by linking them up with a connection. In this case, the connection would be the Pythagorean theorem. You could take the derivative with respect to time, because here you see the variable, the thing that's independent, that's always changing is time. Time keeps on ticking into the future. So you keep on this, you actually solve this, take the derivative using implicit differentiation, differentiate with respect to time, and plug in what you know how this is changing, and then tells you how this is changing.
Pretty
Pretty
cool.
cool. That's called implicit. That's called related rates. Suppose, for example, you drop a stone into a very, very still pool. You have a ripple effect that makes concentric circles that are getting larger. If you know how fast the radius is changing, you can find how fast the area is changing because you have a connection between area and rate. Area equals pi r squared. So there you go. Related rates. You know how one rate is changing, you can find out how a related rate is changing. Okay, what else can you use the derivative for? Well, the other thing you can do is actually graph really accurate pictures of functions. Finally, you can figure out that the parabola looks really pretty and bowl-like, like this. And it's not something really exotic, but it's just a nice pretty bowl. How do you do it? Well, you just start taking derivatives and analyzing things. First, you find the critical points. Those are points where the derivative either equals 0 or the derivative is undefined, but the function is defined. So, for example, in these examples right here, you'll notice that the derivative equals 0 here, the tangent is horizontal right there, the tangent is horizontal here. In this example, the tangent is horizontal here. And then where does the derivative not exist? The derivative doesn't exist here. The derivative doesn't exist there. Those are candidates for maximizing. Those are called critical points. Then what do you do with those things? Well, you set them up on a little number line, the x-axis, and you look at the intervals all around it, and you see whether the derivative is positive or negative. If the derivative is positive, that means slopes are positive, so the function must be increasing. If the derivative is negative, then that means the function must be decreasing. So you can see that the function, for example, here is decreasing, then increasing. Here you can see it's increasing, then decreasing, then increasing. So you can see where it's going up and where it's going down by the sign of the first derivative. That also determines whether you have maxes or mins anywhere. And that's called the first derivative test. Now, how do you figure out the curvature? The curvature is given by the rate of change of the derivative, how the derivative is changing. So what you do there is you take the derivative of the derivative. So you look at the second derivative. And with the second derivative is 0, are potential points of inflection, points where the concavity changes. This is concave up, this is curving upward. This is concave down, this is concave up. So the cup is sitting up, the cup is sitting down, concave down. So here you can see the second derivative is positive, then the second derivative is negative, it changes here. Now it's sitting up, positive, or concave up. Here we're concave up, second derivative is positive. Now here we see it's concave down, second derivative is negative, and second derivative here is also negative. This is a cusp point, the derivative doesn't exist there. This is the point of inflection, this is the point of inflection, this is the point of inflection, and that's the minimum. So just by taking the derivative and then second derivative, you can actually figure out and graph a very accurate sketch of even very complicated, almost scary-looking functions. By the way, that fractional exponents, expect cusps. That's my word of warning of the day. Okay, now, if you got really exotic functions that have denominators, then actually you have asymptotes. So don't forget that a vertical asymptote is where the function, after you simplify it, the bottom equals 0. So wherever the bottom equals 0, after you simplify and reduce, those are going to give you your vertical asymptotes. Horizontal asymptotes, you take the limit as x goes off to infinity, as you go off the horizon, and you see what y value you're trying to land to. If you're landing somewhere, then you know you've got a horizontal asymptote, and so y equals that value. So you put the asymptotes, and then you do all the other calculus, get the curvature, exactly what the big picture looks like. And that was the end of the differential calculus. Great, no problem. Now what? Well, now we move on and look at the exact same thing we just did backwards. So we look at math Jeopardy. Oh my goodness, and only 5 minutes left. So math Jeopardy, here we go. So the idea is, if I tell you what the derivative is, how can you find the function whose derivative is that? Well, this is the notion of an antiderivative. So how do you actually find antiderivative? Well, we sort of want to find the antiderivative of x to the n. It would be x to the n plus 1 divided by n plus 1. Take the derivative of that, so you get x to the n. Unless n equals negative 1, then you're looking at the integral of 1 over x. And what's the integral of 1 over x? What's the natural log of the absolute value of x? Because the derivative of natural log we already saw was 1 over x. So great. Now, how can you find exotic integrals? Well, remember that d dx represents differentiating with respect to x, and so therefore the integral with respect to x represents to integrate with respect to x. Now, if you have a very complicated thing there, with an inside and outside, you might be able to untangle that, which potentially was made by the chain rule, by using substitution. Let u equal some big blob, and the big blob's derivative should appear somewhere else in your integral. If you've got that, it sounds like a good candidate for u to use substitution, and then you've got to change the dx to du by taking derivatives and seeing what du equals in terms of dx. So that's the u to u substitution. You got that going on here. And now what do? You can take that and look at states of motion again. Now I can give you acceleration. If you integrate, you get velocity. If you integrate again, you get position. So vertical motion, not a big deal anymore. Lands, no problem. Things moving in space. Like this thing here. Watch it, folks. You can get that. Anything that moves, anything at all that moves, we can now analyze whether you have crabs or whether you have a bike. It's not a problem anymore, folks. If it's movement, we can differentiate and figure out what it is. Not a problem. Now, Where does this lead us? Well, it brings us back to the very first question of the course, which was how do you find areas under curves? We have to answer that. We haven't done yet. It turns out the surprising answer is that it's the fundamental theorem of calculus. And the idea is if you want to find the area under this curve from A to B, right here, if you want to find that area, then how do you do it? It turns out that if that function is called, let's say, f of x, then all you do is integrate from A to B f of x dx. Because you're summing up little rectangles in here that are base, small change in x, base times height, which is the function you go from A to B, and this equals f of capital F of B minus capital F of A, where what's capital F? That's the antiderivative. So if you take the derivative of capital F, you actually get little f of x. So just find the antiderivative, plug in the big point, plug in the small point, subtract, that will always give you the area under the curve. You could look at the areas of more exotic things. For example, if the thing actually goes like this, then actually, this is actually not very x easy. The rectangles aren't very clear. The rectangles change from going from green to green, over to green to orange, and orange to orange. It's not very uniform. However, if you put the rectangles in this way, and stack them this way, now you're summing with respect to y. And so here you would actually sum this with respect to y, so you would integrate this dy, and put the rectangles in this way, and put the rectangles in that way, and stack from low to high, and you stack the rectangles like this. Okay, that is all of calculus. I did it in under 20 minutes. That's what it is. Go back, think about it, have fun with it. Congratulations, folks. You just finished Calculus 1. Have a good time, celebrate. Good luck in the final. Bye.
So what'd you think?
It was actually so funny. Like when he kept throwing this stuff, it made me laugh.
All right, time for lunch.
I thought it was so funny.
Somebody turn the light on the way out, please.
I wasn't.
Yeah.
I'm missing quiz 125. I was wondering if I could take it today.
Yes, you can.
We already have a lot of them. I didn't send you up an album. I could put one in your mailbox. Mr. Townsend, I have something for you. Look, so I can go on the board right next to Emily.
You can use the magnets that used to cover me.
Wait, you have to read the back.
I have to read the back.
Yes.
What's the back say?
My intentions for next year.
Oh. I don't know if I put that.
Yeah,
I think
you
I
told me
did.
that already. I knew that.
Oh, well.
You already know.
Oh.
There's a back on mine. Did you see it?
I think I like the back better.
You see my dog?
Yeah.
I didn't put a picture of my dog on there. I should have.
You should have.
I took pictures of my dog. Lizzo.
I'm glad I don't get magnets over my legs like Emily.
Yeah, yours doesn't have to be.
Look at the back. There's more pictures on the back.
Now he has to take off all of the magnets.
Good.
Yeah, yours
That's
are
a
very
cute
leggy.
picture. Look, there's 4
yeah.
pictures on the back. You didn't even notice, did you?
You could just turn it that way.
But I like the other picture. It's cute. I like that outfit. It's okay. You can cover my legs back, but. Okay, bye.
That's so funny. Wait, Emily, you can wait. Yes. Or you. I don't know what I'm gonna send it today. You know what? The global just texted me.
Which quiz did you need to do?
The mini quiz over the things that will definitely be in the exams 1 and 2. You did it like either Thursday or Friday last week, I think.
Was it?
Well, let me just look at gradebook. I can probably see what you're missing. Oh, okay. I know what it is.
too. I got 5 minutes now.
Okay, I got 22 after, so let's pick back up. So what I wanted to ask y'all, is it possible to learn calculus in 20 minutes?
Yes.
Could you follow most of what he was saying?
He
It
was
sound-
talking too fast.
I don't think he'd be able to work that just from the system.
Yeah. Yeah, he described U substitution in about 15 seconds.
He didn't do anything for like the volume of, when you run through it.
That's true. Part of, I mean, obviously the video is like mostly just a joke, you know, but also it kind of shows you that if someone's trying to summarize calculus in 20 minutes, all that stuff's important. So it does, you know, like one thing in there that I think y'all would benefit from more practice, and I would definitely consider doing this, would be the tangent line approximations. I put that on a worksheet recently, but I didn't get many questions from y'all, but that was on there. I don't know, just trying to highlight a few things that may be less familiar to you. But yes, the video is mostly for a joke, but he went through, he wasn't doing Cal AB, which is why a few of the things weren't on there. Technically, he said Cal 1, and what we do in here is Cal 1 and part of Cal 2. So that's why like the volumes of revolutions and stuff isn't on there. But he would need a couple more minutes to do those things too. Okay, so what I'd like you guys to do with the second half of class is I would like you to get in one more FRQ practice. This will of course be the last one I ask you to do before the AP exam. And like last class, I will let it be your choice, but please number it as 137. So I will ask for some assignments next week, and if you are not a senior, then of course that will impact your grades. If you are a senior, I will put those things in Google Classroom, and you're welcome to turn them in.
So if we're seniors, we don't have to train anything else after today?
That's correct. Well, because Friday's your last day, so.
Yeah.
But like if I put something in Google Classroom on Monday for everyone else to turn in on Tuesday, if you want to turn it in, I'll put it in the grade book for you. But if you don't, I won't count it as a 0 because
yeah,
you're done. Short of finals, but we don't have a final, so. As far as the homework, I haven't been vocalizing this, but again, this is the last time I'm seeing y'all before the AP test, so please make sure you at least skim through that number 126, which was the AP survival guide, is what I called it. It's got a lot of small things in there, like remembering that your calculator's in radian mode. If you have your own calculator, you know, that's on you. If you're going to borrow a calculator the day of the test, then that needs to be in the top of your brain for when you get it in the second section, because they take our, like you can see, they took up my calculators, and so some of them will be there, but some of them are in degree mode right now, and there's not somebody that's going to switch them to radian mode. The people who run those things don't know that it needs to be in radian mode, so.
Are they going to clear our calculators before the test?
I don't believe that they do. Has anyone taken a science test yet this year? AP?
they don't clear it.
They don't clear it? Okay. Well, I don't know that I would push this hard, but there are a lot of calculator programs out there that could have things like formulas and stuff programmed in, but using them for the first time on the AP test would probably be a bad idea, because you may get stuck in the program and not know how to get out. But there is a section on my website where I show you how you can put programs on your calculator by connecting it to your computer, and there's a website that has thousands of pre-made programs. I have that on there as an ACT suggestion, because if you find a good program and you know what it's good at and you know how to use it, sometimes that could help you out. But I guess that could maybe apply for calculus as well. Is that why you're asking? Or?
I was just curious. So do we have to do our FRQs in pen?
No, you should do pencil. Should be a regular number 2 pencil. I think mechanical pencils usually work fine, but occasionally they don't, like the Scantron part like doesn't scan correctly or whatever, so you could screw your score up by doing mechanical pencil. So. But they should have some extra number 2 pencils for you if you don't have any, but please make sure you skim through that survival guide. It gives you some tips on some stuff to study. If you don't know what to study, reminds you of some stuff you need to think about during the test and right before the test, all that kind of stuff. So again, I try to type it up for you. I don't think I put this on here, but if you have your own calculator, make sure that you charge it or put in fresh batteries before the test, because if it dies on you in the middle of the test, I don't think you can then borrow one, because I don't think you can use more than one calculator on the test. So obviously that would not be good, and it would make it quite a bit more stressful if you were having to adjust on the fly like that. Also, any late incomplete work from the last unit or anything we did on AP review, that is going to be very, very last call for that. Obviously it's late, so it would be late credit, but I will still be happy to give you more points on that, but only if you do it before the AP test. So once the AP test hits, that's it. If your grade ends up falling right below the letter grade you're aiming for, and you didn't turn some of that stuff in, then sorry, but I'm not going to be very sympathetic there. You guys are welcome to email it to me or put it in Google Classroom, or you can bring it by tomorrow, I guess. But after that, anything we did before the AP test over the last several weeks, that would be your last chance. And of course, any time that you can put in towards studying for the AP test may be beneficial. I don't think any of the ones I gave you for this daily meme here, I don't think I gave you the problem that has the potato. There was a real famous FRQ where you had to figure out like the temperature of potato, and people got like really, really high. Oh, I did do that one? Okay, well, I don't remember what year it was or anything, but I know some people got the banana one. Did anyone do that one? Because it was one of the optional ones, so some people did it last class. That's where these things are coming from, they're referring to. So okay, so obviously I don't want you to do the same option, not optional, but it is your option which one you do. So last class for 136, you either did the back page of 128 if you knew you needed an extra practice on rate in, rate out. You did the back page of 130 if you needed an extra practice on particle motion, or you did the back page of 133 if you got more practice on tables and Riemann sums. And if you felt okay with those, then you did a second FRQ from 124, which was all 6 of the 2022 FRQs. And so for our second half class today, I'm going to ask that you do one more, please. It can be your choice. Whichever one you do, though, numbered is 137. And after you give yourself 15 minutes to do that, of course, make sure that you actually check your answers and learn from your mistakes. So, yes, sir.
How was the banana problem proof that atheists are right?
Just because it was like
the amount of bananas?
No, they were just saying, like, is one that students complained about, like being too hard. So the fact that College Board would give you an FRQ that hard is proof that atheists are right. That's the joke. Did you do that one?
Yeah.
I didn't think it was that bad, but
Terrible.
yeah. Every year there's like one or two that students just really stick out and students complain about. So there was one about a spinning top. I think that was 2021. I don't think I made y'all do that one. But then the potato was a year or two before that, and some of them are just kind of infamous for one students complain about. So Okay, so I know you need some time to do that, so I'm going to shut up and let you get some work done, and then I will come around so I can also be of assistance to help you out. But I'll give you 15 minutes in case you're just now starting. Actually, I lied. I kind of want to see which ones y'all choose to do, just out of curiosity.
I'm doing a little bit after this. And the right in right out.
I didn't print it out for anybody else.
Oh,
So,
really?
it's a right in, right out type.
Yeah.
You have to memorize all this?
No, I was just gonna use it as extra shit. It's crazy.
Oh, I didn't know if like they gave it to you.
Yeah, they
They do? You didn't have to memorize the unit circle?
Well, I don't think they really use that. We don't use it. It's just like a lot of things on the other side of it. And there are a bunch of
Class.
physics.
I remember a couple of them. Force of gravity. Yeah, but you still have to like know which one to use. Almost as hard.
Weapons use all the variables.
Find the it's the right variables.
So it kind of,
That's not that bad.
also a lot, it's just like concepts.
Yeah.
You have to share.
For our test too, like as of 2 or 3 years ago, it's become more conceptual where it's like they'll ask you a question to see if you understand what's going on, and less like computational where you have to do like 6 steps of algebra to get an answer. So.
And how that is.
Just good for some people and not so good for others. there's something I can help with, just call me over and let me look at what you're working on as I come around.
I got 6 so randomly too. Like I felt fine until I walked in this room.
You said it's continuous.
No.
I mean, once you get I think you might not get the justification there because you're not saying why you think it's continuous. I think if you said differential, aerial, continuous,
Yeah.
then you're saying
I
why.
know girl goes to OU and I'm mental. And she was
That's
like
why I put that on
$200,000
there.
on this.
That's not obvious at all that they expect that. I think they do.
Dude, maybe should I start vlogging? We need cameras.
Wait, right? You are?
I think I will too. They're loving us. Just summer vlog. I have a camera, I have a camera, and I have an editing software. I have what people just have for editing software. But I might do this.
So you said for seniors, that we don't.
I watched one from the
But,
Yeah, if you do, I'll see your in for you.
I'm surprised she got
Senior
it
grade,
like that.
shortly after. Y'all don't have final, and this is Friday.
I have to show my signature to people. Why?
And I cleared several times, I'd like to get more points for it, but if I take them up, then I'm ready to get back.
I would be coming here for it.
That way for y'all, it's, if you think it'll help bring you up, feel free to turn it in, I can hurt you. If you don't, I'll do it next.
Okay, so for this issue with Q, you get 2 points for WBT. And I put V zone. Is that okay? Like,
Yeah, but they're saying
So
that you
there's-
get the.
there's 2 points for that, so.
I think when they say this, the answer is probably this guy, and then DBDT. I think they're probably looking
I
at
got this
this.
one from, I got this one from online. So I would get both points because I did
Correct.
And, okay.
Yeah, so I think they get 2 points if you found DBDT,
Oh,
and
yeah.
1 point if you got the answer to the question.
Okay. Or no, no one knows about that.
Ready then?
Yeah.
Nothing I can help with? Okay.
Oh my god, what's sorry. Just gonna miss our class. Calculus class.
So y'all did the same one? Oh, I remember that one. This line thing, did y'all struggle with that?
Yeah, I don't know how to see it. I got the answer, but it's not already. You have to have. I just don't know if that would count. Is it like considered H? I don't know what I said.
Yeah, I remember when this one came out, but we read that in front of here, so we talked about. So this line, which would be, they tell you to call it H?
Most of what H is.
Okay. So the length of H would be this function minus this function. So I would say that H is equal to whatever that is minus 1, right? And then down in part D, you want to know
area of cross sections. I think the area apex induces apex is like the side of the image square. So I just H my square. So
She got to wait up
it's
the
change.
I can
That sounds great. I don't
But
remember.
it didn't plus one.
I have to go from a TV video, like where I'm gonna be on camera in my cap and gown. My hair is crazy. Busy getting cap and gown. That's why I didn't wash my hair.
Well, no, that's the
I
same
didn't see
thing.
it.
This is like.
That's like chain roll. It's just a different way to say chain roll.
Because if you say,
Wait.
if you want to know DA, DT, they're just saying you can do DA over DX times DX over DT. And these like cancel. It's just a different type of notation. You don't have to write that at all.
Okay, so I would.
It's only to the side too.
What do you get the same number?
It's in numbers, but God. I'm so sorry.
Oh my god,
I
it's
feel
really
like a really great like.
I don't know. Let me.
I can't look at random stuff. If I see one like that, I'm
Well, this one was number 2, so skipping this one.
No, actually, the very last one. Like I got these two.
But my point is, like, one section of the test is FRQ 1 and 2. So if you skip this,
And we're just done.
yeah, like, you can come back to it later without a calculator, but you may not have time, and like, I think that
You're not gonna have a calculator.
I know too, so I was like, that's final, but we'll do finals on Monday, so that's not much use, but we'll just make that up somehow. I have a quick question.
Okay.
Was this part of 131?
Yes.
Okay, because I turned in 131, but I think I forgot to turn this part in.
Okay. Did I dock you points?
I don't know.
I think you did.
Yeah, I can put 0 out of 10.
Did I get the other page?
Yeah, I did turn in the other page, I just didn't know there was a second page to it. Because I didn't save one.
I didn't give you points for the first page at least?
I guess not, then I don't have it here. And I remember turning in 2 pages and putting everything in one.
My eyes.
You might check.
Well,
Oh, you weren't here last time. I passed back a ton of papers last time.
classrooms now.
Wait, now I'm confused.
I need to look at that graphic in my advisory mouth.
Oh, maybe I didn't turn it in. Okay.
you weren't here last time, I did pass back a lot of papers. Okay, I think I updated it on here already, but double check and make sure.
So like, I got that.